Welcome back. In this video we want to show that the integral of cosec x dx is equal to the negative ln of cosec x plus cot x plus c. Right? So the expression shown there. So let's show that this is the case. To be able to solve this kind of problem, the solution is not very direct. However, if we remember our derivatives and go in the reverse direction, we should be able to find a good expression that we can add here to kind of soften this so we are able to see it better. All right, so to do that, let's start. So the approach, as I've said, is not obvious, and what we are going to do is to find some trick that when we substitute in here is going to make the expression easier to solve, and that makes it really simple. All right, so to do this, the expression we are going to use is cosec x plus cot x. So what we do is to multiply and divide by this expression. If we multiply the integrand, the cosec x, if we multiply it and divide by this expression here, what do we get? So we end up with this, and when we multiply that in, we have cosec x squared plus cot plus cosec x cot x in the numerator. The denominator remains as it is. So of course, by multiplying and dividing by this expression, we haven't changed the expression because that is 1. So if we do that, this is what we end up with. Now, why exactly are we using this substitution? It is because if you have been doing this, you would notice that the numerator is now the derivative of the denominator. In other words, if we let this be u and differentiate, we are going to get the numerator. And we know that if we can express an integral as f prime of x over f of x, if we can express an integral as a function and its derivative like that, then the method of u-substitution works, and that makes life easier in solving this problem. So let's do that. So clearly now it is evident, or you will see, we will show that in fact that numerator is the derivative of the denominator. Let's do that now. So if we use u-substitution by letting that denominator there be u, all right, then differentiating the denominator du by dx gives me, now let's just see this. So cosec is, in fact, I'll write this here, the cosec of x is 1 over sine. 1 over sine, and so I can write this really as sine of x power negative 1. Now if I differentiate this, I will get, so let's differentiate outside first, this is chain rule, so I'll get negative 1 over sine squared of x, and now we go and differentiate the inside, and we will get cosine of x. All right, so that is what the derivative of cosec x is. Now the derivative of tan of cot x, cot is 1 over tan, so I can also write this as tan x power negative 1, and if I differentiate this by the same method, I will get negative, this goes to the front, and I get 1 over tan, the derivative of so this is going to be 1 over tan squared of x, and then the derivative of tan is actually sec squared of x. And so this is how we differentiate cot. We just need to turn them into sine and tan, and then differentiating them becomes easier. So I'm going to write this down there and then see how we deal with this to get the numerator there. And so, based on what we have just found out, and so this is the result we found out for the derivative of cosec, and for the derivative of cot, we found that. All right, now I can split that into 2. If I do that, if I split that sine squared into 2, then I have cosine of x over sine, and the other side I will remain with 1 over sine x, like that. So cosine over 1 of the sine there, and then I'll have 1 sine remaining by itself like that. So of course this is, looking at this is cot, okay, and this is cosec. And on the other hand, I have sec there and I have tan. I can transform tan into sine squared over cos squared. So the cos squared goes up. All right, so that becomes cos squared over sine squared. And sec squared is 1 over cos squared, right, like that. And so the cos squared and the cosine squared there cancels out, and I'm left with 1 over sine squared, which is in fact cosec squared. So if I rearrange that, if I simplify that, I end up with, all right, so we end up with negative, so there's a negative here and there's a negative there, so we can factorize the negative out. Cosine over sine is cot, and 1 over sine is cosec, and 1 over sine squared is cosec squared. And therefore, this derivative, we've found that the derivative of this becomes du by dx is this expression here, which turns out to be what we have in the numerator there, except the minus sign is missing. So I can say that the whole of this expression, including dx there, must be equal to minus of du. All right? So, and this one here is u, so I end up with negative of du divided by u, which we can now differentiate easily. Okay, so then u is given by that expression, and du is also given by this expression as we have determined. If we substitute back into our original expression, this one here, then we can see that is replaced by negative du, and this one will be replaced by u, like that. And so all we are integrating now is minus du over u, which easily is negative ln of u, like that. Okay, but u was given by that expression, so we can write that as minus ln of u, which is this, which I can also express like that. All right, and so this here is the integral of cosec of x. All right, so the integral of cosec x is given by negative ln of cosec x plus cot x, everything plus c, like that. Okay, thank you very much. The next we are going to solve is the integral of sec. All right, it's going to use the same method as we have used in this particular case. See you in the next video.